We got three situations here. We have to create a table and an equation and a graph for each of the following situations. Alright? So, the distance Lily walks in 2 times the number of minutes she has been walking. So we're going to do one together. Situation 1, situation A. Alright, and then the other 2 you're going to do on your own. Okay, as your group, or whoever you're paired up with. Alright? Now, it says in situation A, the distance Lily walks is 2 times the number of minutes she has been walking. 2 times the number of minutes that she has been walking. Alright? Situation B says the distance traveled in a rabbit in a critter race is consistently 1 inch more than twice the distance traveled by the iguana. And situation C says the amount of water in the pitcher is half the time elapsed in seconds. So we're going to look at the first equation. Alright? In the first equation, for situation A, let me step out. Alright, so situation A, our x values are 1, 2, 3, 4, and 5. What would our equation look like for situation A? What would our equation look like for situation A? What you think it would be?
Y equals y equals 1x.
1x? Alright, so look at the situation one more time before you say 1x. It says the distance Lily walks is 2 times the number of minutes she has been walking. So if it's 2 times the number, what would it be?
Y equals 2x.
Y equals 2x.
Y
Plus
equals 2.
0.
Ooh. Yep, so we don't have to write the plus 0, right?
No, we don't have to write it.
And we wanted to make it look direct variation form, right? So notice I start at the bottom instead of at the top, because I like to have the equation done first. Y equals 2x. So I like to do the equation first. Okay? Once I've done the equation, then we work on the table. So Jermaine. I'll work on the equation. Got the equation, now I need to work on my table. Alright, to Marcus.
Sir, what's up?
My table should look like what? Start right here. Yep. The table started right here, right? Yeah. Alright, so if I plug in 1,
Oh, can I do it?
what will my Y be? To Marcus on this one. If I plug in 1, what will my Y be? 2. Bernard.
Sir?
If I plug 2 into this equation, what will my Y be?
Y equals. Oh, it would.
What's 2 times 2?
Oh, 4.
4. Austin. If I plug 3 into my equation, Y equals 2 times
3.
3.
Okay, it's only 3.
2 times 3 is 6. Quay. If I plug in 4 to my equation, what would it
2
be?
times 4.
2 times 4. 8. Blaze. If I plug 5 into my equation, so Y equals 2 times 5. 10. Alright? So now we have our table set up.
Yes, sir.
Notice the increase in the X is 1. The change in the Y is 2 every time, right?
Yes, sir.
So that correlates with my table. Okay, now we're going to do the actual graph. Right? So with the graph, we're going to have to do it this way. Take your X and your Y's and plot them. Alright, so the first X is 1. My Y is 2, so I'm going to plot that one here. 2 and 4. 3 and 6. 4 and 8, 5 and 10.
Straight line.
I don't get what you're doing, man.
I'm taking my X and my Y's, and I'm plotting them on the.
Is this right?
So your first one should be what? First one should be 1, right? 1 and 2. 2 and 4, 3 and 6, 4 and 8, and 5 and 10. All right, now gotta draw your line straight through. So where do you think this is gonna cross on the y-axis? At 0. Very good, Andrew. Don't cross at 0 because it's a direct variation equation, right? So it's linear, therefore it is 0. Yes.
Man, go on.
Okay. Now you're gonna take the other 2
Can you read the directions, please?
and we're gonna work those 2 together. Oh, you're not gonna work them together. We're gonna work them separately. All right. So you're gonna do these on your own.
Can you read
All right. Situation B: the distance traveled by the rabbit in a critter race is consistently 1 inch more than twice the distance traveled by the iguana. You hear the word more than, you gotta think about what term is that in math. More than. That means you're adding. Okay? And we see twice. Twice means 2 times, right? 2 times something. So think about the 2 operations that I just said and how your equation should look. Remember, we starting from the equation, and then we're gonna set up the table and the graph. So let's get started. So if you pair it up with somebody, y'all need to work together. Y'all can go ahead and work together. You know, both of y'all have books. Y'all can go ahead and work together on this one. Okay? Come on. Let's figure out what that equation. Let's figure out what the equation is saying. Figure out what the equation is saying. More than means add. More than twice. More than twice the distance. So 2 times. Twice means 2 times. So when you think of twice, that means 2 times, right? So if I say I'm gonna do this twice, that means I'm gonna do it 2 times. So 2 times. So that's, think about multiplication when you think about time. So think about how that would look as an equation. 1 more than 2 times the distance traveled, twice the distance. So distance would be what? Distance would be that information that we're plugging in, right? More than, so 1 plus 2. And the other way you can write that is y equals 2x plus 1.
This is not,
So how did you come up with that? Time about it.
Damn.
So, your equation. We'll go ahead and finish work and do the same thing for the next 3. So, you multiply by 2. We finished, figured out the equation here. So we see the distance traveled from the bottom of the bracket.
Yeah, that was all. It's also constantly 1 inch more than twice the
So
distance.
when you see more than, that means to what? I said it a little bit earlier. It means to add, right? So twice. When you hear the word twice, Quay, when you hear the word twice, what do you think? 'Cause if I say I'm gonna do this twice, how many times am I gonna do it?
2 times.
2 times, what's the word you just said? Times, right? Times, 2 times. So when you see, when you hear 2 times, what do you think?
2 times 1 and 2.
Right.
Oh.
Alright, so 2 times the distance.
I did not know.
Okay, twice, 2 times the distance.
Oh, wait.
One more than this, so that's 1.
So,
Y equals